Okay, now we're, I know you just skipped number 9, and that's okay. Go ahead and turn to page 43, and let's work on number 10, where we have this little thing that we have to convert into a fraction. This is a repeating decimal, meaning, of course, it goes on forever, and there's a really easy trick to converting these into fractions. You might even know what this is as a fraction, but they get more complicated, so we'll use this one as an example. So the first thing you need to know is that if we call this a variable, if I just set this equal to x, if x equals 0.5 repeating, you're going to see why in a moment. I'm going to create another equation that has something to do with this equation so we can kind of use it to solve. So well, what if I multiply this by 10? Of course, that would end up being 10x. And if I multiply a decimal by 10, just this side, all that does is move that over one place. So what do you end up with? Well, if I just move that over one place, it becomes 5, and then this still repeats, so it's 5.5 repeating. Now here's the cool part about this trick, is that if I take this top equation and this bottom equation and consider them a system of equations, two equations, I can actually use elimination to get rid of this repeating decimal, and here's what I'm going to do. I'm going to subtract this whole thing from this. So you're going to take away this equation from the other equation. So now, 10x minus 1x is 9x. Now the cool part about this is what's going to happen when I subtract 5.5 repeating from 0.5 repeating from 5.5 repeating. Well, what happens is all these 5s and all these 5s are just going to cancel out. So the repeating part goes away, so what you really end up with is just 5 minus 0. You end up with just 5. These kind of cancel each other out. 0.5 repeating forever, subtracting itself ends up with nothing, so it's 5.0 or just 5. Well, now, solve this equation. Divide both sides by 9, and guess what? Your fraction is 5 over 9, and if you punch that into a calculator, you would check your answer. Okay, let's try another one. So 0.74 repeating, you know that means 0.74, 74, 74, 74, 74. So if I just say that this is x, I'm not going to write it like this anymore. I'm just going to say, okay, this is x. X equals that. So now, if I multiply this by 10, it would only move it over to this one digit. So since there are two digits that are repeating, I don't want to just multiply by 10. I actually want to multiply by 100 to get the two digits that are repeating on the other side of the decimal. So if there's two digits repeating, we want to multiply by 100 to move it twice. So again, here's x. So x equals, and if I multiply this by 100, if I just move the decimal twice, I get 74.74 repeating. Just like I did with the last one times 10. Okay, and then I'm going to subtract from that the original equation is x equals 0.74 repeating. And the whole point is that the repeating part needs to go away, needs to cancel, and it does. So if I take 74.74 repeating minus 0.74 repeating, you end up with just 74. And over here, 100x minus x is just 99x. Divide both sides by 99, and now you end up with a fraction of 74/99. And you should always try to see if you can simplify that. And since this only has 3, 9, 11, and stuff like that, this is only divisible by 2. So basically your fraction is done. And then again, punch it into a calculator to check your answer if you're not certain that you're doing it correctly. Okay, we're going to go on to the next example here, 12 and 13. Now, if you read this properly, this is 2 and 4/10 repeating. So you guys know that this is going to be a mixed number. So if I just said 2.4, isn't that really 2 and 4/10? So we don't really need to worry about this 2. We can just kind of put that at the end. It's going to be this repeating decimal with a 2 in front of it. So the trick to this is just worry about the decimal, not so much the whole number in front of it. Okay, so how many repeating decimals do I need to, how many places do I need to move my decimal in order to get this repeating digit to go onto the other side. And of course you see that there's only one repeating digit, so you're going to multiply both sides of this equation by 10. So go ahead and set this up. Again, if I said x is equal to, now again, I'm not even worried about this 2.4 repeating part. I'm really just worried about the 0.4 repeating part. So you can just go 0.4 repeating. Okay? Well, moving that decimal once means 10x is equal to 4.4 repeating. Now I'm going to subtract this original equation from this, so minus x, and the other equation is 0.4 repeating. You're going to subtract this equation from the one that I multiplied by 10, and the reason we do that is so this repeating part cancels. So 4 minus nothing is 4, 10 minus 1 is 9x, divide by 9, you get x equals 4/9. Now that's not the answer, because it was not just it wasn't 0.4 repeating, which is what this is, it was 2.4 repeating. So the answer is really 2 and 4/9. Okay, what if you forgot that you don't really need to worry about this? So let's just do this problem one more time, except instead of worrying about like, oh, do I have to make it a mixed number or whatever, let's just do it the same way we did the first problem. So since you only have one repeating digit, you're still going to multiply by just 10. So separate problem, but the same method. So if the original x is 2.4 repeating, if I multiply that original x by 10, it would be 10x is equal to, if I move that digit over, it would be, and just excuse me for 1 second, I'm going to make a little room here, 0, 2.4 repeating, and you're going to see why in a moment. So if I move that over, it now becomes 24.4 repeating. Now maybe you can see why I moved it over, because when we subtract decimals, we want to line them up. So now the repeats cancel out, so I really just have 24 minus 2 is 22, and 10x minus 1x is 9x. If I divide by 9, I end up with x equals 22 over 9. Now those look like they're different answers. They are not, though, of course, because 2 times 9 is 18 plus 4 is 22 over 9. So you get the same answer. One just becomes an improper and one becomes a mixed number. They are equivalent. Okay, I'd like you guys to go ahead and try number 13. You're going to move the decimal 3 times, so you're going to need to multiply by what to move it 3 times? And hopefully you just said 1,000. So I'd like you to try number 13. You don't need to answer 14. I'd like you to try number 15. And then stop here before you check any answers. So just go ahead and see what happens when you try number 15, and then turn the video back on. All right, hopefully you realize you needed to multiply by 1,000 this time to move it 3 times. So 1,000x moves it over, so the repeating part's going to cancel because you have 3 digits repeating. 1,000 minus 1 is 999. 103 minus nothing is 103. 103 over 999. Okay, next page again, skip 14. Now number 15, there's a little trick to this. But if you were listening to what I said before, how many digits are going to repeat for this one? Well, in this case, you only have 1 digit repeating for number 15. So the reason that you only have 1 digit repeating is because it's not over both these. It's only the 2. So as I said before, you only need to multiply by a power that's going to get your repeating digits to cancel. Okay, so if this is the original x, if x is equal to this repeating decimal, the way you're going to do it is just like before. So again, I only have 1 repeating digit here, so in order to get it to cancel, I only need to multiply it by 10. So 10x is going to equal that, which is 1 point, right? I'm moving it 1 place, 1.2 repeating. Sorry, lights shut off. Okay, lights are back on. So now we're going to subtract from it just the original x. X is equal to just 0. And I'm going to line this up properly just like I want you to. So this is 1.2 repeating, right? So it's going to be 0.1 with the 2 repeating. So now, what do you notice about this? This is kind of unusual, isn't it? Well, let me just move this repeating bar. Let me just put another 2 there. Can I do that? Is that the same thing? If that repeating bar is there, isn't that another 2 here, and then it repeats there also? So now you can clearly see that you can subtract these decimals. They're lined up. So the repeating part's going to cancel, and now you have 0.2 minus 0.1, of course, is going to be what? 2 minus 1 is 1, but there's a decimal there. It's not a big deal. You just are subtracting, but because this 2 repeated, the remaining 2's are going to cancel. And then, of course, 10x minus 1x is 9x. And if you didn't get this, go ahead and back up and rewind and do this over again. Then all you do is divide by 9, and you end up with x equals 1.1 over 9. Now, that doesn't look like any kind of fraction that I've ever seen. So 1.1, if you think of this as just any number where I see a decimal and a fraction, I don't like it. So I need to get rid of that. So of course, if I move that decimal over once, what I'm really doing is multiplying by what? And hopefully you're saying 10, right? And of course, I'm not really multiplying by 10. I'm just moving the decimal both of these. So I end up with 11 over 90. And to get that, to prove to you that that's a repeating decimal that works, 11 divided by 90 is equal to 0.12222, which is our original problem. What if I would have just done it as a decimal? 1.1 divided by 9, well, we get the same thing. I'm going to show you an additional way to do this if you got confused a little bit, so stay tuned. Okay, so you say, well, I don't know which power or 10 if I should multiply by 100. You said that we got to move it twice or once because I don't know what's going on here. Well, let's just say that you see 2 digits here, so you multiply by 100. Let's try the same problem, except let's multiply by 100 rather than 10. Just try it out and see what happens. So if I have 100x and I move this decimal twice, I end up with, see the decimal moving once, twice, you end up with 1, 2, 12, point, and then the 2 repeats. Now if I subtract the original problem from that, this exact decimal as you see it, from the other equation, you end up with, well, 0.12 repeating. And again, you know this is another 2. Okay, so now what do we end up with? Well, don't the repeating 2's cancel here? So 2 minus 1 is 1, and 12 minus 0 is 12, and 100 minus 1 is 99x. Looks different. Don't lose that equal sign. Divide both sides by 99. So you end up with x equals 12.1 over 99. Well, just like this one, this decimal, if I just move this digit over once and this digit, what I'm really doing is I can multiply both by 10. So you end up with 121 over 990. Now, I wonder if that's the same as that. Well, guess what? Both of these are divisible by 11. 121 divided by 11 is, guess what? 11. And 990 divided by 11 is 90. So if I actually just reduce or simplify this fraction, I end up with the same fraction here. So you can do it this way, but you're going to end up having to reduce your fraction. That's the only drawback about doing it this method. Okay, last example. I'm running out of time here. Okay, with this last example, I want you guys just to see if you can memorize this rule. How many digits are repeating? 2. There are 2 digits repeating. You multiply by the number that moves the decimal twice, which in this case is 100. So 100x is equal to, if you move the decimal twice, you end up with 2.01, and then here 201, sorry, 201, point what? What is going to be next? What is the digit? And I see that my time is running out. So I'm going to continue this on the 3rd and final video. Sorry about this. I'll see you in a few moments. Didn't have time for the new video. You guys, here is the way you do this problem. Good luck.